Hello everyone. So this is a question from JEE Advanced 2026 paper 1. For a reversible reaction R to P at constant temperature, both the forward and the backward reactions are first order important elementary reactions. So elementary reactions are those reactions that occur in a single step. Okay. With rate constant Kf and Kb respectively. Okay. At time 0, the concentration of R is R naught and the concentration of P is 0. At any given time, R and P are the concentration of R and P respectively. Okay. Kb is equal to 4 times of Kf given, very important. The correct graphical representation of the reaction is, okay, so we have few graphs where in the x-axis we have time. In the y-axis we have the concentration ratio, that is R by R naught and P by R naught. Okay. So we have to determine which one of the graph is correct. Okay. So the chapters involved is chemical kinetics. For the reversible reaction R to P, Kf is the rate constant for the forward reaction and Kb is the rate constant for the backward reaction. Okay. So at time t equal to 0, concentration of R is R naught and concentration of P is 0, that is given to us. And at time t, concentration of R is R naught minus X, obviously, and concentration of P is X. Okay. Because the molar coefficients of both are 1. And question has given this R naught minus X as R, and question has given this X or the concentration as P. Okay. So, and also it is given that Kb is equal to 4 times of Kf. Okay. So I can write Kf by Kb is equal to 1 by 4. Okay. And we know that for a reversible reaction R to P, equilibrium constant K is equal to Kf divided by Kb, which will be equal to concentration of P at time t when we have reached equilibrium divided by the concentration of R at time t when we have reached equilibrium. Okay. So therefore I can write, and we know the value of Kf by Kb, so I can write concentration of P at time t when we reached equilibrium divided by concentration of R at time t when we reached equilibrium is 1 by 4. Okay. So at time t equal to 0, you can see sum of concentration of R and P is R naught plus 0, that is R naught. And at time t, the sum of concentration of R and P is R naught minus X plus X, which is again R naught. Okay. So we know that at equilibrium, the concentration of P is this, the concentration of R is this. So I can write at time t equal to 0, sum of concentration of R and P is R naught, as you can see, R naught. And at time t equal to t when we reached equilibrium, sum of concentration of R and P, that is R plus P, is R naught minus X plus X. Okay. As you can see, it is R naught minus X and X at time t. So which is nothing but R naught again. Okay. So let's assume the concentration of P as X and the concentration of R as 4x, because the ratio between them is 1:4. We just found it out. Okay. So therefore I can write x plus 4x will be equal to R naught, because we know that R plus P concentration is equal to R naught. Okay. So therefore I can write 5x is equal to R naught, and therefore x will be equal to R naught divided by 5. Okay. And we assume P as x, so therefore concentration of P will be equal to x, which is equal to R naught by 5. And we assumed R as 4x. So I can write concentration of R will be equal to 4x, that is equal to 4 into R naught by 5. Okay. So from this, I can write concentration of P divided by concentration of R naught is equal to 1 by 5, which is equal to 0.2. And from this, I can write concentration of R divided by concentration of R naught is equal to 4 by 5, which is equal to 0.8. Okay. So therefore, I can say that at time t, when we reach equilibrium, T by R naught is equal to 0.2 and R by R naught is equal to 0.8. Okay. Now, let's look at the options. So in option A, at equilibrium, so we have determined the value of these guys at time t equal to equilibrium. So we have determined that R by R naught is 0.8 and P by R naught is 0.2. R by R naught is 0.8 and P by R naught is 0.2. Okay. In A, at equilibrium, P by R naught and R by R naught both are 0.5. So you can see P by R naught is 0.5 at equilibrium. This is when they reached equilibrium. And even R by R naught both are 0.5. So therefore it is ruled out. This cannot be the correct answer. Okay. In B, at equilibrium, R by R naught is equal to 0.2, you can see, and P by R naught at equilibrium is 0.8. Okay, which is incorrect because P by R naught is actually 0.2 and R by R naught is 0.8. So therefore, B is also ruled out. Next, coming to option C, at equilibrium, R by R naught is equal to 0.8 and at equilibrium, P by R naught is equal to 0.2. Okay, which is correct. And also value of P by R naught starts from 0. You can see it starts from 0. Since at time t equal to 0, concentration of P, this is 0. That's why it starts from 0. And it increases exponentially to a final value of 0.2 at equilibrium. Similarly, value of R by R naught starts from 1 because at time t equal to 0, concentration of R is R naught, so R naught by R naught is 1. And it decreases exponentially to a final value of 0.8 at equilibrium. So therefore, C is the correct answer. Okay. And in D, the values of P by R naught, these values, so this is P by R naught, so it keeps on increasing exponentially, and R by R naught, that is this, keep on decreasing exponentially, which is incorrect. Okay, so this is our P by R naught and this is our R by R naught. Okay, so this is incorrect, therefore this is also ruled out. So therefore the final correct answer is option C. Okay, thank you.